Hello students, welcome to EduCell. In this video we are going to discuss about counting inversions. Basically, counting inversion is the name it suggests. If the array is in unsorted way, or might be if you have any unsorted array, means the numbers are in not sorted. Sorted doesn't mean that it should be ascending order always or descending order always. Any order, but that should be sorted order. We say the array is sorted means either 1 to the greater number, lower to greater, or higher to lower. That is, we said is sorted. Unsorted means any random numbers which do not have any sorting analysis, or might be sorting steps are not getting involved. We say these array are unsorted for us. So counting inversion helps us to suggest how many number of steps needed to make that unsorted to sorted. Okay, I must write uh, definition of it. The definition suggests the number of you can say operations needed to make the unsorted array to a sorted array is called as counting inversion. Okay, so the counting inversion suggests we need to count it, the number of operations or the number of steps. That could be better rather than the operations. It could be quite confusing. Number of steps, that could be very helpful to understand. Number of steps needed to make the unsorted array to a sorted array is called counting inversions. Or in other sense also, when you search for internet, you will definitely get so many definitions. There I found one of the definitions. I found how far or close an array is from sorted, means that means exactly the number of steps needed to make the unsorted array to sorted array, or to make the sorted array from the unsorted array. Okay, we need the number of steps only. That much we want. We do not want the steps, or do not want to convert it first. No, we just want a basic idea. Only this much steps are needed to make the uh, unsorted array to a sorted array. Okay, this is what counting inversion is. And why divide and conquer approach is helpful for this problem. Also, we will discuss that one. Okay, as we know, we are following the approach because of to reduce the complexity. Complexity, in other sense, you can say it's a time or might be space. Okay, might be somehow we feel decrease the time, so definitely we will use that approach. Okay, because previously if such certain approaches are there which do not have any other approach to reduce the complexity, so we are not following that one. Okay, we are following if any other approach helpful for us to reduce the complexity, that's why we are following it. Okay, so you can check it here just for one simple example. As we said, number of steps needed. As I have collected the information from Tados PPT, the book written by the author Tados. I collected from it, like from the PPT. I collected the information there because I told you repeatedly, like in all the videos, I'm following the book which is written by Corman and other co-authors, as well as the book which is written by uh, Tados and other co-author. Okay, so here you just check it. Just for example, the brute force method. Okay, brute force method to find counting inversion. means we need to find out a number of steps needed or required, okay, to make the unsorted array to a sorted. Now you check it here. As for the example, we will be checking brute force. Brute force, the meaning of brute force is the initial one, or the hit and trial method, like that. This is called as brute force in algorithm. Okay, so you can check one array is given to us. From this array, we have to find out the number of steps needed or required to make it sorted. Okay, in merge sort, in the previous video, we have seen we will uh, be sorting it. Okay, and in the previous video of introduction divide and conquer, we got to know like how it is getting divided. Again, from those who are new to this video, kindly check the previous videos for detailed information about it. Here the example is suppose 4, 3, 2, 1, again 5, and here you can say expect 6. Okay, or here suppose you got 5, here suppose it's 6. Yeah, here it is suppose 4. Okay, now our target is to find the number of inversions. Okay, why? Because this is our part of the curriculum. Now we need to find a way. So as for the brute force, we need to check the for ascending order. Basically, the counting inversions we are following is an ascending order or increasing order. I am just writing it. In the book, it is clearly mentioned counting inversion, but it is not mentioned anywhere that increasing order is considered here. Okay, so in general, we are following the book. The book actually they are following increasing order as a sorted one. Okay, so here we know if we sorted this array, we know the sorted array could be written as this is unsorted array. Okay, unsorted array, and we know if we'll sort it means in increasing order. If I'll write it, so the correct answer could be 1 will be the first, 2 will be the second, and third, 4, 5, 6. This would be our sorted array. Okay, so this would be our sorted array, but we need to find the number of steps included here. This is what the counting inversions. Now from the brute force, how the mechanism will work, that we will be discussing now. We know making it sorted, we know the answer could be writing like this. Now I am just doing one thing. I am just running loop. Okay, so for loop I am running, which will I am starting from, though I started the index, here I am writing the index 1, index 2, index 3, 4, 5 and 6. As for the index, I'm just writing from I started from 1 to the array length. Okay, arr length, which is you can say indirectly it is 6. Okay, again within that array, though it is brute force method, we have to first check it. We have to just check and swap. Okay, next j will be starting from I plus 1, like though we started from this end, and we have to check with the immediate index of it to the arr length, means array length. Array length is the maximum size of the array, it says, means the array length here is 6. Why? Because the 6 number of elements are there, that's why we assign it's 6. Okay, if you started from 0, that will be written as array length minus 1, because you started from 0. That's why we have to just focus with the array length with the 0, means 6 with the array length, and though you started from 0, so 1 minus that you are doing. Okay, so though you are doing 1 minus, so you are getting 5 instead of 6. So it based on the algorithm. Now I am just writing the algorithm for the brute force method. Okay, this is the algorithm for brute force method. Okay, this is within the for loop. Next, what we have to do, we will say inverted if this is a, we must say the a of I, clear, a of I, here I must have to clearly write it. If I is less than j, and a of I is greater than is greater than A of j, we must say is inverted or inversion needed. Inversion plus plus means we have incremented the inversion, or might be we must say one inversion is needed, else no inversions, no inversions needed. This is the algorithm for brute force method. Means we do not have any approach, we simply follow our own approach to check how many number of steps needed. In general sense, I'm just again changing the color now. Suppose you started I from this end to 6. Now we started j because I plus 1 is the initial point and we have to stop. Here we have to check whether I is less than j or not. Here in this case 5 and 3, we know I is 1 and I is 2, but j is 2 now because j is started from this. So we have to check I is j. If this, then and means we are just using to check this as well as this. If this happened, then only we can say inversions we have to consider. Okay, so here we found here j value is 2 and I value is 1. So what we have to do? Why j value is 2? Because j is I plus 1. That's why we there in, exactly 2. Okay, now our target is whether a of I is less than, whether this a I must change because small a is getting introduced now. This a represents the array because here we have changed it. Now the color, if a of I is greater than a of j, then we must say inversions plus plus. Okay, whether here is it forming this one, 5 is greater than 3, yes. If 5 is greater than 3, definitely 3 will be in front of 5. Okay, so that's why we must write inversions. Here the inversions will be 5 is to 5, 3. I'm just changing the color now. I must say the inversions in this way. Inversions are as follows. Okay, 5 is to 3. When we are at this, now we have to find, there will be change. Now I value is at this side. Okay, within that we have done it at the j, because for loop, the first for loop from I is 1, we once it is completed, then only we can switch to I value will be incremented as 2 until it is not completed, because inner loop should run first. Okay, once we will be getting into the upper one. Once we are inserted in the inner for loop, the inner for loop, once it is stopped, then we go to the top loop or the upper loop. Clear? So first we found now j value is getting incremented to this, but initially the I will never change. Okay. Now j is at 3. We have to check whether I is less than j or not. Here I was 1 and j is 3. Yes, this happened. Next what we have to check? Next we have to check whether a of I is greater than a of j or not. Okay, a of I is greater than a of j or not. If such things happened, we must say yes, inversions occurred. Here 5 is greater than 2. Definitely one more inversion is needed. So here we can say 5, 2. Okay. Now j value is incremented. J value is at fourth location, we have to check whether I is less than j or not. Here I is 1 and j is at fourth, means 4 index. So this will be done next. A of I is less than or greater than a of j. Here we found a of I. A of I always we are targeting here. A of I should be less than. If it is less than, no inversions. If a of I is greater than the a of j, so inversions are needed. Means number of steps needed to sort it. Okay. So in this case, we know 5, 1 could be a part of inversions. Now j value is incremented. Here j value we are having I was 1 and j is having 5. So in this case, this has happened done well. Now the value here, we once we compare, a of I is greater than a of j. That's why the inversion is needed. Okay. Now once it is done, so j value is at 6. Okay. Here we found I is less than j, no one, not an issue, but a value, a of I, which is 5, is not greater than 6, means is less than 6. So no inversions needed. Why? Because a of I value is small. Now we reach at this I value is 2 and j value started from I plus 1, means we started from here. So here in this case also, once we have checked this condition, 2 is less than 3. Once it is done, so we should switch to the a of I and a of j condition. Here we found 3 and 2 inversions are needed. Next we reach j here. So we found 3 with 1 the inversions needed. Once we reach at here j value, here for a of I is less than a of j, so no need for inversions. You must write it simple as 0 or no need to write anything, because a value do not we shouldn't move that one. Okay, because we got a of j value is greater than a of I. So here in this case j value we got a of I is less than a of j, so no need to do the inversions. So for case 3 we have ended this one. Okay, now when we are at this location, once we found I is at 3 and we started j, now we have to check whether I is less than j or not. Here I value, ith index is 3, jth index is 4. So we know 3 is less than 4. This condition satisfies. Next we have to check whether a of I is greater than a of j or not. Yes, if yes, then you write conversion is needed. Okay, so now we found this approach well. Okay, next 2 will be compared with other two objects. Here 2 is less than that, so no need to worry. Here I value is here and j value is at the next, very next to it. Here we found uh, I value means the a of I is less than a of j, so no need to inversion, no need for any inversions. So the next we have to check for 6, no need of inversions. Now I value will be incremented. Now I value is here and j value is here. So here we found a of I is less than a of j, so no need for any inversions, means no need for any steps or no steps required to make this as sorted. Okay, only this much are needed. So the counting inversion, if anyone asked you questions, what is the conversions, what is the number of, what is the counting inversions, so you simply add it like 5 3, this is 1, this is 1, this is 2. Okay, so do not circle it while you are writing the answers. Better you just write in this way, like 2 3 could be converted, 5 2 could be converted, 5 1 could be converted, 5 4 could be converted, 3 2 could be converted. Like this you count it: 1 2 3 4 5 6 7. So counting inversion is 7 means 7 steps needed or required to make this unsorted array to a sorted array. So in this way, the time complexity, if you can ask me the question, then in brute force method, sir, why we are switching to that, we will be discussing. First of all, we should know the approach. We will be discussing the time complexity. Now, in time complexity, basically we found for loop is getting used. So big of n now. So here though it is inner loop, so big of n square. Within that we are using. So n into n, that's why n square. And this is big of 1. This is big of 1. This is big of 1. Because any conditions or any statement is written is termed to be big of 1. So time complexity would be the maximum is n square due to inner loop. Okay, so always two for loops or two while loops is written means that doesn't mean that you are getting the time complexity as n square. No, never. It's based on the condition always. Here the condition we know we have to reach to the array length. We are following the loop invariant properties. Then only we can say the complexity. Loop invariant should hold. Otherwise we cannot find it. Clear? Now we should switch to the counting inversions, like how divide and conquer will help us. Okay, you can check divide, conquer, and combine. There are three steps. Uh, we are now using it. Definitely, I told you from the beginning. We are following the approach means we will reduce the time, or might be we are getting some benefits. That's why we are following that approach. Okay, we have completed the brute force one where the complexity was n square. Now we try to reduce it. How much we don't know, but we will apply it. Clear? So separate into two halves, a and b. Suppose one array is given to us, we have to just separate it. Next, in concur, recursively count the inversions. Recursively count inversions. Okay, the inversions we will count in each list. Then what we have to do, count inversions a and b with a b means it means exactly the two sub array, or you can say the separated two sub arrays what we got. We have to do it recursively and we will find the way for the counting inversions. Okay, now a return some three counts means it means the combinations of divide, concur, and combine. These three approach, if you add it, the total will say the counting inversions. Okay, now you check a small example we will take here. Clear? 2, 4, 5, 6. So we are simply taking 6 elements inside an array. The array elements could be written as 10, 12, 10, 12, then 1, 5, then 3, 2. Clear? Suppose these are the elements we have. What we have to do is we have to now use the divide and concur approach, divide, concur, and combine approach, and we try to find out what's the counting inversions. Okay, so in this way we have to first separate the two arrays that we know that could be divided into this approach p plus r divided by 2. So p, if you can say, if you started from 1, the indices are like this. So p is 1 because it's initialized, then last is 6, so total is 7 by 2, so which is 3.5. Floor function of 3.5 is 3. So you can do this thing. Okay, first we divide, but we divide in equal halves. Clear? Sometimes if you do not have 6 or might be even number of elements, might be it is depending on the number of indices, we have to follow the queue. Based on the queue we are actually dividing. Here if instead of 6, if it is 5, so you can say 5 plus 1 is 6, 6 by 2 is 3. So from this, the left hand side could be 3 elements and right hand side could be 2 elements. So as we have already studied in merge sort, this is in following the approach. Okay. Now you simply write the elements as it is. This is what we have to follow. We have to follow the counting inversion. We first divide it. Once we have divided, next process is to check the counting inversions. Okay, here whether it is first, here you can run the I. Okay, I and j within the same portion. So here I will start it from this and j will be started from this end, and we need to reach from here to there, and we need to reach from here to this. So whether 10 is greater than 12 or not? No. Okay, next I value will be shifted. Next I value is at 10 and j value is previously at 12. We found j is greater than I. This condition satisfies. As well as we have to check whether a of I is greater than a of j or not. Here a of I is not greater than, so no need for any inversions. Now j value is getting shifted here. Now we have to check whether I is greater than j or not. Here you can say I is 1, 2, 3. J value is 3. 3 is greater than 1. So this satisfies whether a of I is greater than of a of j or not. If yes, then inversion occurred. So here 10 is greater than 1. If 10 is greater than 1, so inversion occurred. So you must say here the inversion is, under this you must write 10 1, then put a comma. Okay, next I value is incremented here and j value is here. We have to check whether j is greater than I or not. Yes, 3 is greater than 2. Now value of I is greater than value of j or not. Yes, here we found. If yes, so we must say inversion occurred. Now here you can check 4 5 6. You start I value, I, here j. So 5 is greater than 4, but the value here is greater than this. So inversion could be written as this. Next j value will be at 2. So here we found 5, 2 could be next inversions for us. Next I value is getting incremented to 5 instead of 4. Now we got 3, 2. These are the inversions. So here the counting inversions we are getting as 2, and here the counting inversions we are getting as 3. Okay, so here it is 2, here it is 3. We just divided and we have done it. Next procedure what we have to do is, we have to go for combine the things. When we are combining, we need to sort the elements first, then we start combining. This is what our approach is. So we need to sort it. Which one? The sub array which was previously divided. Okay, this is what previously divided, 10 12. So we need to sort it first. Okay, next 2 3 5. First we sort the previous sub array. Sort the previous sub array, then do the combine. When we are doing the combining, we need to say the counting inversions for it. Must be writing, we are not exactly, it's better not to do the same thing, you know, keeping the elements in a array. We must write the inversions. Okay, here I will start. Now we will be writing the thing. Dividing the procedures, we have done the division. Now while counting the inversions, this is what we are doing. Recursively we are counting the inversion in each list. In each list we are counting the inversion. Now what we have to do in combine process, in combination process or combining process, our main target is, I must write it here, in combining our main target is we have to first sort it. We have to sort it. In combining, we must have to sort it. Sort the previous array. This is what we have to follow. Now you can start I from here to there and J from here to there. Okay, this is what you have to do, the counting inversions. Here this is 1, 2, 3, here it is 4, 5 and 6. Once you are doing the operation from I starting from 1 to 3, I starting from 1 to 3 and J starting from 4 to 6. In this case, we try to find whether any inversions needed or not. Here I is at 1 and J is at 4. Here I is less than 4 or not. That's that condition we have to check. Next condition is number of counting inversions. So if A of I is greater than A of J, then only we do the conversions or counting inversions needed. Here 1 is less than 2, no need of conversions of this one. Next, I value is fixed, but J value is shifted to 5. Now we have to check whether A of I is greater than A of J or not. Here we found 1 is less than 3, so no need for any conversions. Like this we found 5 is greater than 1, so no need of any conversions. Next, I value is shifted to 2. Now from 2 we have to check other sessions. Here we found when we are at fourth location, here we know I value is less than I index is less than jth index, but the value here we found is A of I is greater than F j, so conversions needed or inversions needed. Instead that we are writing 10 with 2. Next, once we found it, we fix the ith location. Inner loop is working now. We have to check 10, then 3 could be inverted because ith value should not be greater. If greater, then inversion is needed. 10 with 5, this done, this is completed once we checked with this. Next, 12 is greater than this, so we must write the inversions in this way: 2, then 12 with 3, then 12 with 5. So the counting inversions are, total counting inversions are 1, 2, 3, 4, 5 and 6. 6 with the combine, we are finding this one as a concur. This is combine. Okay, this is combine. This is a concur. Through concur process we found this much, and through combine process we got 6. So total inversions needed, total inversions, total counting inversions could be, total CI could be equal to 2 plus 3 plus 6. These are for concur. This is from combine. So total will be 12. I must write it here. Total counting inversion is 12. This many number of counting inversions are needed. This is what the approach is. Okay. Now we have to follow the algorithm which we followed. The algorithm here is written. Okay. We are following the mod sort. Through mod sort we try to find out the counting inversions. Though directly we can say equal halves. Also, it is written clearly when you do the equal halves. It is written like this. So T of n was previously writing this. So two equal half we are finding. So n by 2 and n by 2. So 2 n by 2 instead of that we are writing. And though combining we are doing, or which merge previously we are getting as big of n. Those who are new, kindly check the previous video where we discussed in about the merge sort, and we know how to find the time complexity. There we discussed. Yeah, this is what uh, the recurrence relation of counting inversion. The recurrence relation of counting inversion is, I must be writing this one, a recurrence relation. A recurrence relation could be written as Tn equal to 2t n by 2 plus theta of n, or sometimes we might ignore that one, or this is what the, through this we can say the time complexity would be. We recently found this as big of n log n base 2, because we are equally dividing into two halves. That is why the base is 2 here. Okay. The other reason is by keeping base as 2 is only that we are dividing into two equal halves, or might be two unequal halves, but 2 is our main target. That's why we kept there. Okay. More short, it's written well. We are doing more short in equal halves, then we do the merge. Merge is combine, basically we are doing. So these are concur. I must write these are concur, and this part is combine. Okay. So the time complexity we have already studied. So better we can say it's n log n. Here we can say it's n log n. Here we can say it's big of n. And we know the maximum. First of all, we first add it. As per here, we know if we'll add it, the time complexity could be big of 2n log n plus big of n. So here the maximum is 2n log n, but 2 is constant, so you may remove it. C into n log n you can write, or n log n you can write. But here this is what we can expect the correct answer as n log n. Okay. So I hope it is clearly understood by you. If any problem you're facing, please comment below. Thank you. Have a good day.